3I Atlas is no longer just a scientific marvel, it's a massive concern. The latest official observations of the interstellar object, 3I Atlas, show dramatic changes that have caused alarm among space agencies. These truly unbelievable new images and data confirm the comet is exhibiting highly volatile and actually dangerous behavior. Specifically, the unprecedented acceleration and unusual energy output of 3I Atlas are raising critical questions about its nature and trajectory. Read our urgent report now to understand exactly why the world is watching this celestial object, and what the unsettling implications of the 3I Atlas's dramatic shift could be. Right now, as you listen to these words, an object from another star system is passing behind our sun. Hidden in the glare, invisible to our eyes, it moves silently through the inner solar system. A wanderer born under a foreign sun, made of frozen materials older than Earth itself. Astronomers call it 3I Atlas, the third interstellar object ever discovered. But this one is different. It is brighter, larger, and more chemically alien than anything we have ever seen. And the story of how we found it is stranger than fiction. Imagine this: a chunk of ice and rock forged billions of years ago in a system that no longer exists. For eons, it has drifted between the stars, through radiation fields, shock waves, and cosmic dust, until gravity from our sun finally pulled it in. It is now cutting across our celestial backyard, a brief visitor that will never return. And yet, within the few months that we have been watching it, 3I Atlas has begun to behave in ways that make even veteran astronomers uneasy. When NASA and the James Webb Space Telescope turned their instruments toward it, the readings seemed impossible. The ratio of carbon dioxide to water vapor in its surrounding cloud, its coma, was not 1:1 or even 2:1, but 8:1. 8 times more carbon dioxide than water. No comet in the history of astronomy has ever shown such a composition. It is as if this object were built from the frozen breath of a different kind of world, under conditions our solar system never knew. That single number, 8:1, sent quiet ripples through the scientific community. Some researchers whispered about exotic chemistry. Others suggested that its surface had been cooked by billions of years of cosmic radiation, sealing away the water beneath a crust of carbon dioxide. But none of the explanations truly fit. And while the data poured in, NASA's public statements remained calm, even casual. The press releases spoke of a typical interstellar comet. Nothing dangerous, nothing mysterious. Move along. But behind those polite words, something did not add up. The activity of 3I Atlas was increasing faster than models predicted. Its coma was swelling, its color deepening to a reddish hue, a sign of complex carbon molecules, the same kind found in organic material. Spectral lines shifted as though gas jets were erupting from specific cracks, not evenly across the surface. It was not a quiet, frozen rock. It was alive with motion and changing week by week, as if awakening from a long sleep. To most of the public, it was just another headline lost in the noise of daily life. But to those who understood what this meant, 3I Atlas was a once-in-a-lifetime event, a chance to peer into the chemical heart of another solar system. Every atom escaping from its surface carries a story about its birthplace, what its star was made of, how cold its cradle was, and how ancient its origin might be. If decoded, that story could rewrite what we know about planetary formation and even the ingredients of life itself. Still, the unease remained. If the object's behavior could not be explained by known physics, what else were we missing? Was it possible that interstellar space harbors materials or processes we have never encountered before? Could there be something inherently unstable, even volatile, about its chemistry? These are not the kind of questions scientists like to ask in public. Yet privately, many began to admit that 3I Atlas is not behaving like any comet born in our system. It is, by every definition, an outsider. And that raises an uncomfortable truth. If something so large, so fast, and so alien can enter our solar system without warning, what else might be out there, unseen, waiting its turn? The more we study 3I Atlas, the more we realize how fragile our sense of cosmic safety really is. We live in a system that is open to the galaxy, a place where visitors can arrive unannounced from unimaginable distances. Our telescopes caught this one. But how many pass by unnoticed, beyond the reach of our light? So tonight, as we trace its orbit through the blackness beyond the sun, let us look closer. Beyond the technical reports, the scientific restraint, the careful language of discovery, there is something profoundly human at stake. The unknown has come to visit, again. It carries with it not just frozen gases, but questions about who we are in this vast and permeable universe. What if 3I Atlas is not merely a comet at all, but a fragment of another cosmic story, one that began before our own world was born? Because somewhere, far behind the sun, a silent messenger is gliding through the light. Its icy body reflects a past we cannot remember, and a future we can barely imagine. And as it slips across the hidden side of the sky, one thought lingers in the minds of those who are watching. Maybe this is not just a comet. Maybe it is something we were never meant to find. The object we are talking about has a formal name. Astronomers call it 3I Atlas. The name sounds cold and technical, but it holds a quiet piece of history inside it. The part that says 3I means this is only the third time in all of recorded human science that we have ever seen an object that came from outside our own solar system. The part that says Atlas comes from the system that first flagged it, an early warning network built to look for hazardous asteroids. Except this time, it did not find something local. It found an intruder. To understand why that matters, we need to talk about what an interstellar object actually is. Most comets and asteroids in our sky were born here. They formed from the same ancient disk of gas and dust that surrounded the young sun more than 4.5 billion years ago. They orbit the sun like family. An interstellar object is not family. It was created somewhere else, around another star entirely, under different temperatures, different chemistry, and different radiation. It does not orbit our sun. It only passes through. Before 3I Atlas, we had only two of these visitors. The first was Oumuamua, discovered in the year 2017. It was small, dark, and strangely shaped, and it accelerated in a way that nobody fully explained. The second was Comet Borisov in the year 2019, which behaved more like a normal comet, but was clearly not from here. Then, for a while, nothing. The universe went silent again. And now, years later, this new arrival appears. Only the third, only number 3 in all of human history. But here is where things turn from rare to unsettling. 3. I Atlas does not just pass through politely. It is big. Early estimates suggest a solid core that may be several kilometers across, possibly more than 10 kilometers in diameter. That makes it larger than the previous interstellar visitors, maybe by a wide margin. It is not a pebble. It is not a loose fragment. It is a full-scale icy body, the sort of thing that, if it ever struck a planet, would not leave survivors to tell that story. You are looking at a world-killer class of mass. And it is fast. Everything in space moves, but this moves like a bullet fired from another galaxy. By the time we detected it, 3I Atlas was already racing through the inner solar system at a speed of hundreds of thousands of kilometers per hour. That velocity carries enormous kinetic energy. In simple terms, if something that large and that fast hit a planet, the impact would release the energy of many global nuclear arsenals at once. This is why astronomers take objects like this so seriously, even when they say, "Do not panic." The good news, the official line, is that there is no threat in the immediate sense. Based on its current trajectory, 3I Atlas will not collide with Earth during this pass. The closest approach to our planet is expected to be more than 1 8/10 astronomical units. An astronomical unit is the distance from the Earth to the Sun. In other words, it will stay farther away from us than the Sun is. On paper, that sounds safe. On paper, it sounds like a non-event. This is how agencies keep the public calm. But safe distance does not mean harmless, and harmless does not mean unimportant. There are two things that make scientists lose sleep. The first is timing. We found this object only shortly before it moved through the heart of the solar system. We did not see it coming 10 years out. We did not have a decade to prepare a mission to meet it. We caught it on the way in. That means, if its path had been just a little different, we could have faced a high-energy interstellar impactor with almost no warning. The second thing is what it represents. 3I Atlas is proof that our solar system is not sealed off. It is not isolated. We live inside a gravitational crossroads. Visitors can and do arrive from deep space, not in science fiction, not in theory, but in real life, right now. They arrive carrying unfamiliar chemistry, unfamiliar structure, and unfamiliar behavior. We did not build our defense systems with that in mind. Our asteroid surveys are trained mostly on local objects. But this is not local. This is foreign material moving at foreign speed. Now think about what that means scientifically. This thing was born elsewhere. Its ices and dust condensed around another star. The temperatures were different. The radiation bath was different. The balance of carbon, oxygen, nitrogen, and metals was different. Every molecule locked in its body is a physical message from that other birthplace. Studying it is like drilling a core sample out of an alien protoplanetary disk without ever leaving home. This is why astronomers are desperate. This is not just a comet. This is a sample return mission from another star system that the universe delivered to our doorstep. And we only ever get one pass. The path of 3I Atlas is not an orbit. It is a hyperbola. That means it is not bound to the sun. Our gravity grabbed it for a moment, bent its path, and will then let it go forever. There will be no second encounter, no later flyby, no chance to go back and take a closer look in 100 years. When it leaves, it will leave for good, and it will take its chemistry, its story, and its warnings with it back into interstellar night. So, when you hear people call it a comet, understand what they are really saying. Comet is the closest word we have, but it is not the right word. 3. I Atlas is an interstellar intruder. It does not belong here. It is older than our world, faster than anything we can launch, and large enough to matter. It has crossed light years to fall briefly into our light. We are watching it now. We will never see it again. It began, as many astronomical discoveries do, not with a shout, but with a flicker of light. In the quiet hours of July 1st, 2025, the Asteroid Terrestrial Impact Last Alert System, or ATLAS, scanned the southern sky from its twin observatories in Hawaii and Chile. Amid countless faint dots that filled the night, one speck refused to behave. It moved too quickly, its brightness fluctuated strangely, and its trajectory did not fit any known near-Earth object. A few lines of raw data triggered a cascade of alarm. Atlas was designed as an early warning system. Its job is to spot potential impactors, asteroids that might collide with our planet. When the computers flagged this object, the initial calculations were ominous. Its path seemed to approach the orbit of Earth, and its speed suggested a massive kinetic energy. For a few tense hours, it was logged as a potentially hazardous object. Messages were exchanged between observatories, analysts rechecked coordinates, and emergency protocols quietly stirred behind the scenes. Within a day, other telescopes turned to look. Gemini South in Chile, the Subaru telescope in Hawaii, and amateur astronomers from South Africa to Spain all joined the chase. The first images showed a faint, diffuse glow, a coma, a sign that the object was not a solid rock, but an icy body shedding gas and dust. That simple clue ruled out one danger, but opened another mystery. It was active, and active objects move unpredictably. Astronomers needed better data, and they needed it fast. 48 hours after the first alert, orbital calculations began to converge. The numbers looked strange. Instead of tracing a long oval curve around the Sun, the trajectory was hyperbolic. Too open, too wide, as if the object were merely passing through. The eccentricity value was greater than 1, meaning it was not bound to the Sun at all. This thing was coming from outside the solar system, and that changed everything. The fear of an impact turned into the astonishment of discovery. When the confirmation went public, the news rippled through the scientific world. Emails with the subject, "Possible Interstellar Object," flooded observatory networks. Research groups dropped what they were doing. The International Astronomical Union assigned a temporary designation, C-2025A3, Atlas. But when its speed and orbit were confirmed, the label changed again. It became the third officially recognized interstellar visitor, and its new name carried the mark of history, 3I Atlas. The third of its kind, and perhaps the strangest. What followed was organized chaos. The sky survey teams began a frantic search through old data archives, looking for what astronomers call pre-covery images, earlier photos where the object might have been captured by accident. Every bit of extra information helps refine its orbit. From the European Southern Observatory to amateur backyard cameras, the hunt stretched, back through months of images. And there it was, faint, ghost-like, already visible in late June and even May, unnoticed until the right eyes looked. Each new point of light tightened the calculations. It confirmed beyond doubt that 3I Atlas was not born here. Its path cut through the plane of the solar system at a steep angle, descending from the outer darkness at a speed no local comet could match. Once the orbit was plotted, something else became clear. It had likely been drifting in interstellar space for millions, perhaps billions, of years before this brief encounter. What we were seeing was not a new object, but an ancient one waking in sunlight for the first time. Inside data centers, servers glowed through sleepless nights. Observatories scheduled emergency observation time. News outlets scrambled for quotes, but the scientists barely had time to speak. They were racing against the clock because each passing day brought 3I Atlas closer to the Sun, and soon its brightness would overwhelm small telescopes. The James Webb Space Telescope was queued for a special observing slot, using its infrared eyes to probe the chemicals boiling off its surface before it was lost to glare. At first, the mood was cautious. Many researchers remembered the frenzy around Oumuamua in 2017, when speculation had spiraled far beyond data. This time, they wanted to stay grounded. Yet, as the first spectra came back, the calm professionalism began to crack. The composition was unlike anything in our solar system. The ratio of carbon dioxide to water vapor defied expectation. This was not just another comet. It was a chemical time capsule from an entirely different cosmic nursery. In just 3 days, the emotional pendulum swung from panic to fascination. What began as a possible threat had turned into a scientific miracle, a messenger from another star system falling through our neighborhood. The change was almost poetic. Fear transformed into curiosity, anxiety into wonder. Humanity's first instinct had been to protect itself. Its second was to understand. And that is how the race began. A global, sleepless, coordinated pursuit to capture every photon, every whisper, every secret that 3I Atlas was willing to share before it vanished forever. Across the world, scientists watched the faint point of light move night by night against the backdrop of constellations. The panic had faded, but the sense of urgency remained. They knew they were witnessing something history would remember. For the first time, the community acted not as separate nations, but as one species, united by a fleeting visitor that cared nothing for our borders. Out of chaos came collaboration, and out of fear, the purest form of human drive, the hunger to know. And somewhere, far out beyond the orbit of Mars, the interstellar intruder continued its silent arc, unaware of the storm of attention it had created. It did not slow down. It did not turn. It simply followed the ancient line that gravity had drawn for it long before human eyes existed to see. By the time the world realized what it was, 3I Atlas was already on its way toward the sun, and the clock had started ticking on our only chance to learn its story. When the James Webb Space Telescope first locked onto 3I Atlas, most scientists expected something familiar. They thought they would see what they always see when a comet warms in sunlight: water vapor boiling off the ice, and a faint cloud of gas forming a halo around the nucleus. That is the pattern we have known for decades. That is how comets behave in our solar system. But what Webb actually recorded was not familiar. It was not even close. It was a chemical shock. Using infrared spectroscopy, Webb can read light the way a chemist reads a lab report. Molecules absorb and emit light at very specific wavelengths. Water leaves a signature. Carbon dioxide leaves a different signature. By spreading the light into a spectrum, you can tell exactly what gases are being released and in what amounts. It is like pointing a scanner at an alien iceberg and asking it what it is made of. This is how the first real surprise arrived. The data showed something that should not exist. The coma of 3I Atlas, the cloud of gas and dust boiling off its surface, was not dominated by water. It was dominated by carbon dioxide, not slightly dominated, overwhelmingly dominated. The ratio of carbon dioxide to water vapor was measured at roughly 8:1. That means for every faint breath of water released, there were around 8 parts carbon dioxide. No comet that we have ever studied has looked like that. Not one. To understand why that matters, imagine standing next to a campfire and finding out that most of the heat is not coming from the flames, but from the ashes. That is how backward this is. In our solar system, comets become active because sunlight warms their icy surfaces and water begins to sublimate. You get jets of water vapor, and those jets carry dust and organic particles into space. That is, comet behavior 100. Carbon dioxide is present, yes, but usually as a secondary driver. Here, it is the engine. So what could cause that? One idea is birthplace. For carbon dioxide to freeze into solid ice, the environment has to be extremely cold, far colder than the regions where most comets in our solar system formed. That suggests that 3I Atlas did not just come from the outer edge of some alien star system. It may have formed beyond that edge, in a region so distant and so dark that carbon dioxide ice was not only stable, it was abundant, maybe even more abundant than water ice. In other words, this body might have been born in a deep freeze that makes our Kuiper belt look warm. The second idea is damage. Picture a body wandering unprotected through the galaxy for billions of years. No magnetic shield, no thick atmosphere, just naked ice in hard vacuum, absorbing cosmic radiation, micro-impacts, charged particles, and ultraviolet light from passing stars. Over that kind of time, radiation can strip lighter molecules from the surface, break apart water, drive it off, and chemically harden what remains. The outer crust becomes processed. The deeper interior stays different. By the time we meet it, the object is wearing a scar. In that version, the 8-to-1 ratio is not telling us how 3I Atlas formed. It is telling us how it survived. The idea is that the surface is caked with carbon-rich material and trapped carbon dioxide, while water is either sealed deeper inside or already eroded away. That would explain why the outgassing we see is not uniform. It seems to be venting in focused plumes, almost like pressure leaks from fractured seams, rather than bleeding evenly across the whole surface like a classic solar system comet. Either way, the conclusion is the same. 3I Atlas does not match the chemistry we see in local comets. That alone is historic. For planetary science, chemistry is biography. The balance of carbon, oxygen, and simple volatiles tells you how far from its star the object formed, how quickly it cooled, what kind of disk of gas and dust existed in that system, and even what sort of planets were likely to grow there. By reading those ratios, you are basically reading the birth certificate of a solar system that is not our own. There is something almost unsettling in that. It means we are not just observing a visitor. We are sampling a different recipe for building worlds. In our own system, we believe water-rich comets may have helped deliver water to the young Earth. We use that model when we imagine habitable planets around other stars. We picture icy bodies carrying oceans to rocky worlds. But what if, in other systems, the default delivery truck is not water at all, but carbon dioxide and complex carbon chemistry? What kind of ocean does that create? Now take a step back and imagine what we are really holding in front of us. This is physical evidence that planetary systems can assemble in ways that we did not predict. It challenges the quiet assumption that our solar system is typical. For many years, we behaved as if our model was the template. We assumed that out there, it is more or less like here. Then along comes 3I Atlas, and it calmly says, no. Life elsewhere may begin with a very different pantry. That is why some scientists describe this as a once-in-a-civilization moment. We have, for the first time, a direct chemical fingerprint from deep inside another planetary nursery, and that fingerprint does not look like ours. It is not subtle. It is not a rounding error. It is a ratio so extreme that it breaks our standard comet physics. It says, go back and rewrite the model. It says, you have been thinking too locally. It says, the galaxy is stranger than you allow yourselves to admit in public. There is also a quieter undertone that people are not eager to voice in press conferences. If the surface of 3I Atlas has been altered by billions of years of exposure to raw interstellar space, then it is a physical witness to that journey. The radiation, the particle storms, the gravitational slingshots, the slow erosion, the sealing of its skin, all of it is recorded in its outer layers. Studying those layers is like reading travel scars on a relic older than our sun. It is forensic cosmology. And so the 8-to-1 ratio is not just a number. It is a message in plain sight. It tells us that this object was born cold, tempered by deep time, and released into our neighborhood carrying chemistry that did not evolve here. When you look at 3I Atlas, you are not only looking across distance, you are also looking back across age. You are seeing conditions that may have existed before Earth had continents, before Earth had oceans, before Earth even existed at all. It is tempting to say this is like finding a frozen ocean from another world. But that is not quite strong enough. This is more like someone left a sealed vial from an alien planetary nursery on our doorstep, rang the bell, and ran. The vial is hissing open right now, under the light of our sun, spraying out gas we have never measured in that proportion before. We can watch, we can learn. But we only get this window once, and when 3I Atlas leaves, that window closes, and the vial goes with it. When the first close-up images of 3I Atlas began to arrive from observatories around the world, the data told one story, but the pictures told another. On the screen, the comet did not appear calm or static. Its form was restless. The cloud of gas and dust surrounding its nucleus, what astronomers call the coma, seemed to swell, shimmer, and change shape every few nights. It was as if the object itself were breathing, exhaling strange gases from fractures hidden beneath its icy surface. From the Gemini South Telescope in Chile, the coma appeared faint and bluish in early July. But just a few weeks later, observers noticed a transformation. The brightness increased, the envelope of gas expanded outward, and the color began to shift toward a deeper, rusty red. That hue is not just aesthetic, it means something chemical. A redder coma suggests the presence of complex carbon compounds, long-chain molecules that absorb blue light. It meant that this visitor from another star was releasing not only ice, but organic material. Across the ocean, the Las Campanas Observatory in Chile and the Very Large Telescope in Paranal confirmed the trend. Spectra taken at different times showed that the gas composition was not constant. New emission lines appeared, faint at first, then strong. The object was changing under our eyes, evolving on a scale of days. No one expected that level of activity so far from the sun. Normally, comets need to come much closer for solar heat to awaken them. But 3I Atlas was already venting vigorously, as if impatient. Astronomers began to describe its behavior with words usually reserved for living systems. Breathing, pulsing, awakening. In truth, this was not metaphor alone. The physics of the coma really does resemble respiration. Gas trapped inside the nucleus warms, expands, and escapes through weak points in the crust. When the interior cools again, the pressure drops, and the outgassing slows. In time, another area fractures and releases a new jet. The entire surface acts like a lung of ancient ice, inhaling sunlight, exhaling gas from a forgotten world. But what startled everyone was the directionality. Instead of releasing gas evenly in all directions, 3I Atlas vented in asymmetric plumes. One side of the nucleus was more active than the other, creating a jet that pushed material sideways, bending the tail and twisting the coma. The images from James Webb confirmed this asymmetry. Infrared mapping showed bright hotspots where the outgassing was concentrated, as if cracks had opened like vents under pressure. The object was not rotating smoothly. It was struggling, shedding mass in bursts. Each burst of gas carried dust particles into space, particles that then reflected sunlight and changed the object's appearance. The coma thickened, the tail lengthened, and the faint halo grew more structured. You could even see streamers, thin, curved lines where the dust was being sculpted by sunlight and the solar wind. Observers who compared photographs taken weeks apart could hardly believe they were looking at the same body. The red, the brightness, the shape, all of it kept evolving. The comet was alive in every visible sense. The term alive does not mean biological, of course. It means dynamic. But for scientists used to studying frozen relics that barely move, this level of activity felt almost emotional. Imagine finding a fossil, expecting it to be stone, and then seeing it twitch. That is what it felt like to watch 3I Atlas. The ice that had been asleep for billions of years, traveling through the dark between stars, was suddenly awake, reacting to the warmth of a new sun, a chemical heart beating once more. Why was it so reactive? One answer lies in its composition. Because its surface is rich in carbon dioxide, it can begin to sublimate much farther from the sun than ordinary water ice comets. Carbon dioxide ice turns to gas at lower temperatures, which means the process of activity begins earlier, long before sunlight becomes intense. 3I Atlas is like a deep space sleeper whose alarm clock went off too soon. Even at a distance of hundreds of millions of kilometers, it was already boiling at the edges. The other possibility is that internal heat was being released. As sunlight penetrated fractures, volatile gases trapped in deeper layers could have warmed rapidly, causing small eruptions. The pressure builds, a crustal patch bursts, and a jet sprays material at supersonic speeds. This, in turn, spins the nucleus slightly, exposing new regions to sunlight and triggering yet more eruptions. It becomes a feedback loop, a cascade of reactions that can transform a quiet comet into a roaring, twisting engine of dust and light. If you could stand nearby, though you would never survive the radiation or the vacuum, you would not hear sound, but you might feel vibration through your boots. Each venting jet would release momentum, shaking the nucleus. Dust grains the size of sand would drift like slow-motion snow, illuminated by the distant sun. The red hue would tint everything around you like dusk through smoke. And above, the thin line of the tail would stretch for hundreds of thousands of kilometers, faint but eternal. In many of the long-exposure photographs, the coma appears like a living organism, translucent layers expanding, fading, and reforming. The tail bends gently, like a streamer caught in a breeze. These changes are not illusion. They are the record of time itself, of heat and chemistry transforming an alien body hour by hour. Scientists studying the images describe it as non-linear evolution, meaning that the object is not just following a formula, it is unpredictable, it is reacting. It has moods, at least in the physical sense. There is something quietly poetic in that. For millions of years, 3I Atlas drifted in silence, frozen and forgotten, waiting for any star to pass, close enough to wake it. Now, under our sun's touch, it burns away pieces of itself for us to see. Each plume, each brightening, each change of color is both a revelation and a death. It is sacrificing its outer layers so that we can learn what lies inside. It is dying to tell us its story. Astronomers often say that a comet is a time machine, a relic of the early days of a solar system. But this one feels more like a messenger that still breathes. Its coma is not an atmosphere, yet it behaves like one, fluid and restless. Its tail is not a flame, yet it flickers like fire. What we are witnessing is not the cold geometry of orbit, but the drama of transformation. Matter meeting light, ice meeting heat, history meeting now. From a distance, the coma of 3I Atlas may seem small, just a faint blur against the black. But inside that blur are molecules never before exposed to our kind of star, carbon chains that have been sealed since before the Earth existed. As they vaporize, they tell us about chemistry older than our Sun, and perhaps chemistry that can lead to life elsewhere. Every shift in color, every new jet of gas, every tiny pulse is data, and every pulse whispers the same thing. It is not dead ice. It is active, evolving, breathing gas from another world. For most of human history, the oldest things we could touch were stones. Then we learned to read the age of fossils, and we held bones from creatures that walked the earth before our species existed. Then we learned to date meteorites, and we realized we could hold fragments from the birth of the solar system itself. But what we are looking at now is older still. 3. I Atlas may be made of material that predates our sun. You are not just watching a comet. You are watching ancient matter from before our own beginning. We know this not because someone guessed, but because the numbers demand it. When astronomers calculated the path of 3I Atlas, they did not see a looping orbit. They saw a one-time crossing, a hyperbolic arc that begins far beyond our reach and ends far beyond our reach. That path, along with its extreme speed, means this object is not native. It is not part of the icy debris that formed with our sun. It is a drifter, a refugee from another system. And that fact opens a much deeper question. How long has it been drifting? To drift through interstellar space is not a short trip. You do not leap from one star to the next in a single graceful hop. You wander. You fall past one star, get slung outward by gravity, and continue on. You pass through shock waves from ancient supernovas. You get battered by cosmic rays. Your surface gets cooked and scarred. This is not a journey of 1,000,000 years. This can be the journey of 1,000,000,000 years, possibly more than that. 3. I Atlas may have been traveling longer than complex life has existed on Earth. That is hard to hold in the mind. Imagine something older than the continents. Imagine something older than the oceans. Imagine something older than the sun. Our sun is around 4.5 billion years old. The gas and dust that later became the solar system fell together, heated, and became planets. If 3I Atlas truly formed around a different star before that event, then it carries trapped inside it the chemical fingerprints of a world that lived and died before ours was even born. When astronomers talk about that kind of age, they also talk about metal. Not metal the way we use the word in daily life, but in the astronomical sense, elements heavier than hydrogen and helium. Young galaxies are poor in metals. Older galaxies, enriched by dead stars and supernova explosions, are metal-rich. If 3I Atlas formed around a star that was old, low mass, and metal-poor, then its makeup would be different from most comets in our system. Less water ice in some layers, more carbon dioxide, more primitive carbon chemistry. That is exactly what we are seeing. There is another layer to the story. 3. I Atlas is not just old, it is experienced. Think about what billions of years of exposure to open space actually means. Every micrometeor strike leaves a crater measured in grains. Every burst of ultraviolet light cracks molecules and reassembles them into tougher chains. Every cosmic ray alters bonds, turning simple ices into complex organics, into dark, reddish crust. The object becomes a scar record. Its surface is a diary of deep time, written in chemistry instead of ink. Now consider the path it might have taken. To cross the distances between stars, 3I Atlas could have passed through crowded regions where stars are born, where gravity kicks are violent. It could have skimmed through the outskirts of dense clusters. It could have drifted past stars nothing like our sun, red dwarfs, fading embers, aging giants. Each pass would have pulled on it, changing its motion. Each pass would have rewritten its path just a little more. Over eons, the original orbit is erased. The birthplace becomes unknowable. That is part of why we cannot point to a specific parent star. By the time we find an object like this, its navigational history has been scrambled. We can say it is interstellar. We can say it is ancient. We can say it did not come from here. We cannot say which dawn it remembers. In a way, that mystery is honest. The galaxy is not neat. It is violent and eroding. It does not preserve origin stories for our convenience. It throws them at us and dares us to reconstruct them from fragments of ice and dust. But there is one thing we can do. We can read the ratios of elements inside that ice, the balance of carbon to oxygen, the presence of certain isotopes, the trace amounts of metals. Those numbers are not random. They are fingerprints. They tell us about the temperature of the disk, where this object formed. They hint at how quickly that disk cooled. They suggest what kind of worlds could have formed in that system. Rocky worlds, icy worlds, worlds with atmospheres rich in carbon dioxide, worlds with oceans that did not look like our oceans. If you step back, you see the scale of what that means. 3. I-Atlas is not just a traveler. It is a fossil from a long-dead solar system, a shard from a planet-building factory that no longer exists, or that has changed beyond recognition. We do not need to send a probe to another star to learn how other systems make planets. One of those systems has already shed a frozen witness, and that witness is right here, for a moment, lit by our sun. And that is the quiet shock. This object is older than human civilization, older than Earth as a living world, quite possibly older than the sun itself. You are looking at time made physical, not a myth, not a model, a real fragment of a vanished dawn passing through our sky. When people first heard about 3I Atlas, the question came almost immediately: is it dangerous? NASA and the European Space Agency answered quickly and calmly. No, they said. Its trajectory is safe. It will not come anywhere near the Earth. The closest point in its path is more than 1 8/10 astronomical units away, nearly twice the distance between the Earth and the Sun. There will be no collision, no fiery streak through our skies. The headlines moved on. But that was not the end of the story, because not colliding is not the same as not dangerous. The real threat is not what is happening this time, but what this object reveals about how unprepared we are. When the first alert for 3I Atlas went out, it was already moving through the inner solar system. We discovered it only a few months before its closest approach. If its path had been just a fraction of a degree different, if it had been on a slightly altered course, we would have faced an interstellar impactor, and we would have had almost no time to react. Even a small body, just a few kilometers across, traveling at interstellar speed, carries almost unimaginable energy. The velocity of 3I Atlas is more than 100,000 kilometers per hour, far faster than typical comets or asteroids from our own system. Energy increases with the square of speed. That means that a rock only a few kilometers wide, moving this fast, would strike with the power of millions of nuclear weapons combined. It would not matter where it hit, it would erase that place from the map. So, when scientists talk about danger, they do not mean we should fear this specific comet as a weapon. They mean we should pay attention to what it exposes, the holes in our cosmic awareness. We depend on a handful of survey telescopes to find threats in time, but even those instruments were caught by surprise. They are tuned to spot local objects, not visitors arriving from deep space. Interstellar bodies move too fast, too faint, too briefly. We saw 3I Atlas only because we happened to be looking at the right patch of sky at the right moment. That should make us uneasy, because if one interstellar object this large can slip through our detection net, there will be others. Maybe smaller, maybe darker, maybe coming from an angle we do not expect. Our entire defense strategy, from early warnings to potential deflection missions, assumes time. Years, sometimes decades, between discovery and impact. But interstellar visitors offer no such luxury. They arrive at extreme speeds, they cross the solar system in months, and by the time we notice them, the window to act is already closing. And there is another, subtler kind of danger. The biological and chemical kind. Every time a comet sheds gas and dust, it releases materials into the interplanetary environment. When that comet comes from another solar system, those materials are not familiar. They have formed under alien conditions, exposed to radiation and chemistry we do not fully understand. When they drift into our region of space, they mingle with the solar wind and the outer fringes of our atmosphere. No one can say with certainty what long-term effects, if any, those interactions might have. To be clear, this is not about science fiction. No one is suggesting alien microbes hitchhiking through space. The fear is subtler. Unknown compounds, metallic dust, reactive molecules that behave differently under our sunlight or in our magnetic field. The gases escaping from 3I Atlas contain nickel, carbon dioxide, and organic fragments that we have never measured in such proportions. We know they are harmless in tiny amounts, but we have never modeled what happens when tons of that material sweep through a region of planetary space. The danger is not only in physics or chemistry, it is systemic. When 3I Atlas was discovered, no single global plan existed to coordinate immediate study or response to such a body. NASA and the European Space Agency had to rearrange observation schedules, borrowing time from other missions. Smaller observatories scrambled to point their telescopes before the object faded. The reaction was impressive, but improvised, a reminder that our planetary defense network is still young, still reactive, rather than proactive. It is sobering to think that a civilization capable of launching telescopes to the edge of the universe can still be caught off guard by a frozen stone drifting through our neighborhood. 3I Atlas is a warning written in ice. It says that space is not empty and that our system is not isolated. We live in a galactic traffic lane. Some travelers pass peacefully, others might not. The next one could be darker, faster, harder to see, and if we rely on luck to notice it, one day luck will fail. So yes, 3I Atlas is not about to strike the Earth. It will glide past, and in a few months, it will vanish back into the dark between stars. But the danger it represents is still real. The danger of complacency, of assuming that distance equals safety, of trusting a fragile network of instruments to watch the entire sky. The real risk is not the impact we can see coming. The real risk is the one we do not detect in time. 3. iAtlas is not only a threat assessment exercise, it is also a gift. For the first time in human history, we are watching an active interstellar object up close while it is still venting material into space. That means we are not just seeing a rock that once passed near another star. We are directly sampling a living chemical system from beyond our sun. Every plume of gas that escapes its surface is a message, a sample, a data point from a solar system that is not ours. With the James Webb Space Telescope, we can do something that was impossible even a few years ago. We can measure not only what this object is made of, but how it changes with time. We can watch the balance of water vapor, carbon dioxide, carbon monoxide, organics, and trace metals shift as sunlight warms different layers. That is no longer just astronomy. That is comparative planetology. We are, in effect, running a lab experiment on the building blocks of an alien planetary system without leaving our own. This matters because chemistry is the first language of worlds. The mix of carbon, oxygen, nitrogen, and simple ices tells us what kinds of planets could have formed where 3i-Atlas was born. Was that system cold and slow-forming, favoring deep ice giants and carbon-rich surfaces? Or was it violent and hot, stripping water early and leaving behind carbon dioxide and heavy compounds? By reading those chemical clues, we learn how common or rare our style of planet-making truly is. There is also a deeper question under all of this, a question that quietly makes people hold their breath. Life. We do not know how common life is in the galaxy. We only know that on Earth, life seems to love carbon, water, and energy. If 3i-Atlas is rich in carbon-bearing molecules, if it carries complex organics forged in the dark between stars, that suggests that prebiotic chemistry may not be locked to our sun. It may be portable. It may be shared. The seeds of habitability may travel. That idea changes the way we talk about isolation. For a long time we treated solar systems as sealed rooms. Now we are seeing that they leak into each other. Frozen bodies are ejected, wander for ages, and then pass through foreign light, releasing their chemistry into new neighborhoods. Material moves, information moves, ingredients move. If that is true, then maybe life is not something that happens in one rare oasis. Maybe the galaxy keeps mixing the recipe over and over until it works. There is urgency here, too. We will not get another chance at this specific object. Once 3i-Atlas swings past the sun and drifts outward, it will fade below the limits of even powerful ground telescopes. Its coma will collapse. Its plumes will quiet. The door will close. Every spectrum we take now, every image, every timing of every jet, will become part of a permanent record. Future scientists will study this event the way we study the Apollo samples from the moon. So yes, 3i-Atlas is strange. Yes, it is fast. Yes, it reminds us that we are vulnerable. But it is also a treasure. It is a courier from another star system, carrying molecules older than our oceans, releasing them into the light where we can read them. If the universe keeps sending us visitors like this, again and again, maybe it is not just an accident. Maybe it is an invitation. Maybe it is the way the universe says, you are not alone. As 3i-Atlas sweeps through the inner solar system, all eyes are fixed on the moment astronomers call perihelion, the point where it comes closest to the sun. That will happen in late October of the year 2025, when sunlight will strike it with full force. Every telescope capable of seeing it, from the James Webb Space Telescope to ground observatories in Chile and the Canary Islands, will be watching. What happens during those weeks will decide what we learn and what is lost forever. When the object rounds the sun, it may flare brightly as its surface heats. It could split, shedding fragments that drift outward like sparks from a slow-motion explosion. Or it might survive, sealed by its carbon crust, and then fade quietly into the dark. Either way, the data will pour in. Infrared spectra, visible images, radio measurements of gas flow. Scientists are preparing for sleepless nights, aligning instruments across continents, knowing that once it passes behind the sun and reappears, it will already be dimmer, already slipping away. After that, the long goodbye begins. The light curve will fall, the coma will shrink, and the once brilliant tail will dissolve into the solar wind. Within months, even the largest telescopes will lose sight of it. It will become just another faint moving dot in archival files, a line of numbers in orbital databases. Then, eventually, nothing. The object will head back into interstellar space, unbound, drifting between stars for another eternity. The story of 3I Atlas will end where it began, in darkness. But its legacy will not end there. The observations we gather now will shape the next generation of sky surveys. Projects like the Vera Rubin Observatory, with its massive mirror and ultra-wide camera, are designed to capture the entire sky every few nights. It will see faint, fast objects that older telescopes could never catch. Along with NASA's upcoming NEO Surveyor mission, it will expand our reach, building a system that can spot the next interstellar visitor long before it gets this close. For the scientists who study small bodies, this is more than astronomy. It is the birth of a new discipline, interstellar studies, or interstellology, as some call it half-jokingly. A field dedicated not to planets or stars, but to the messengers that drift between them. Each visitor carries clues about the chemistry of its home system. By collecting enough of them, we can build a map of the galaxy's material diversity, the way geologists map the layers of Earth's crust. 3. I-Atlas is only the beginning of that map. There are already conversations about what to do next time. Could we build a rapid response mission, a spacecraft ready to launch within months of a discovery? Could we intercept an interstellar object while it is still inbound, before it swings past the sun and leaves forever? NASA's proposed Comet interceptor mission, though designed for local targets, might become a prototype for that. The technology exists. What is missing is the urgency, the recognition that these fleeting visitors are opportunities measured not in years, but in days. If we succeed, the next encounter will not end with fading light. It could end with samples, grains of dust, molecules, isotopes gathered directly from an object born under another sun. Imagine holding that in a lab, a fragment of alien geology, a piece of cosmic history older than the Earth itself. That would be more than science. It would be contact, not with another civilization, but with another origin story. A handshake across light years, written in ice and carbon. So what happens next is both simple and profound. 3. I-Atlas will vanish beyond our reach, leaving behind data, questions, and a sense of awe. New observatories will rise, new instruments will scan the sky, and one day soon, another point of light will move in ways that no local object should. When it does, we will remember this one. We will remember how close we came to missing it, and how much it taught us in the brief time we had. The next interstellar visitor is coming. The question is, will we be ready? The story of 3I Atlas is not only about a comet, it is about contact. Not contact with another species, but contact with another origin. A body born around a distant star has crossed our path and opened itself to our instruments, spilling its chemistry into our sunlight. In a single pass, it has shown us that the galaxy is not silent, and that our solar system is not sealed. We live in open water. Things drift in. Things drift out. We are not alone in the flow. 3I Atlas also exposed something uncomfortable. For all our pride as a technological civilization, we are still almost blind. A world-scale object from deep space entered our neighborhood, and we almost missed it. We had no mission ready to meet it, no standing plan to intercept it, no language, even, for the urgency of studying something that will never return. We like to imagine that we are in control of our future. This visitor quietly reminded us that we are not. And yet, there is a kind of hope in that. Because for a brief moment, the whole planet looked up together. Telescopes from continents and space all turned to one moving point of light. Scientists dropped old rivalries to chase data before it vanished. People who never cared about comets before suddenly whispered words like interstellar and ancient. Wonder, real wonder, is still possible. Curiosity is still stronger than fear. That matters. So here is what remains when the object is gone. This is not just a comet. It is a messenger. It is a warning. It is proof that the universe can reach in and tap us on the shoulder. But it is also an invitation to build faster eyes, an invitation to prepare, an invitation to admit that we are part of a larger story than Earth, or even the Sun. The question is no longer, what is out there? The question